Good morning, everybody. First, a quick poll before we dig into the presentation. How many people are running Kubernetes experimentally? Maybe on your local computer in the cloud. Basically, you're testing Kubernetes. Okay, a few hands. Is anybody running a production workload in Kubernetes? Anywhere? Nobody? Okay, that's okay. Today, I'm hoping to dig down and explore Kubernetes with you. You might find this presentation gives you enough information to make the call that Kubernetes is not a good fit for your organization. And if that's true, if you are able to learn enough about Kubernetes in this presentation that you can make that call, that is still a valuable outcome, and I would be happy to see that result. There's a page on the WP Campus website on my session where you can submit questions. It might not be working, but there'll be a chance to answer questions at the end of this talk. But first, a little bit of background on why I'm giving this talk today. My name is Matt Lauer. I'm a web administrator and developer at Carleton College. My background is in web development. My current role is a mix of production systems, managing and administration, developer tools, workflows, and automation tools to move data around, and code deployment processes. It's very similar to what some organizations will just call a DevOps role or a site reliability engineering role. My first project on the team that I'm on right now involved retiring a 10-year-old physical development server, moving source code out of Subversion into Git. And it turned out after we started those two efforts, we learned that the production server also was kind of decrepit, falling down more frequently than we wanted, and it was on a CentOS release that was soon to be end of life. So we realized that the development server tools and source code work that we were doing could also be used to provision a production server. We used Ansible primarily to drive that project forward. It's kind of starting from the ground up with a new approach, new version control software, new development environment provisioning and configuration tools, and that went all the way through to the production environment. That was mostly a success. We had Vagrant in there for local development. That didn't go quite as well because the application had some assumptions about where it lived and IP address availability. And basically, Vagrant is not on a privileged network, and our application required a privileged network to do some of its work. So it didn't. There were some systematic barriers with Vagrant. But Ansible was mostly a success. Our team had benefited from these automation tools around a big CMS application, an in-house CMS called Reason, and it was mostly a success. Moving forward, we're starting a new project at Carleton to kind of re-envision the CMS. As an aside, this book mentioned on the slide called Accelerate confirms that software delivery performance impacts IT and organizational success. They correlate performance to business outcomes. Higher education is increasingly dependent on IT operations, and it would be a little naive to assume that we are exempt from these conclusions, even though IT is not the driving factor in a higher education environment. Most of your institutions would have severe problems if the IT department became less performant, let's say. But this book is not relevant to my talk today, but it was just published and I'm reading it right now, and it's a great book about why automation, lean management, DevOps, and all that stuff drives business performance and drives success for the organization. And that's sort of an underpinning theme for one of our big projects at Carleton College. There's a new multi-year initiative to reimagine the CMS and web applications. We already started out at a good place by having automation tools for an in-house product, so we were familiar with automation tools, but we wanted to make a strategic investment away from managing an entire CMS ourselves to use open tools, use WordPress so we can utilize plugins, have better access to development resources and plugins and themes from the broader community, and we didn't have to do all of that ourselves anymore. As an operations person, I see this project, I see we're going to have WordPress, we're going to have some development in other environments, but one of the other prongs of this project is to break down and expose data at the API layer and perhaps not at the database integration layer to kind of democratize data and expose it to campus members so that they can develop against it. We have lots of students that would like access to a weather database or a course database, or sometimes a people database, maybe accepting a terms of use policy. But we want to use best fit software, expose data, and all of this to me as an operation person looks like sprawl. I see a lot of new services, WordPress, databases. Some people are looking at GraphQL. We're talking about APIs and API gateways. There's probably other applications. I know that Omeka has a big presence on campus, and people want that to grow. All of this together means we're going to be running more software, but we're not necessarily getting rid of all of our existing software. So we needed a new level of abstraction to kind of help us push this velocity forward to drive the growth of this web project. We determined that Kubernetes is that abstraction layer. Kubernetes is a platform to automate container deployment and management, and it's also an infrastructure abstraction layer. Kubernetes, again, it's a container application platform that helps you run applications in production. It has value to many different roles in the IT department. I'm going to start with the developer here, and most of today's talk is focused around the developer and the operator perspective on Kubernetes and executing and creating a Kubernetes environment. The developer is empowered by Kubernetes to deploy applications quickly, deploy new instances, deploy large-scale application changes. An operator or system administrator benefits from Kubernetes because they get a consistent automation and monitoring platform where they have tools that are out of the box and supported to deploy applications consistently, to monitor applications consistently, and Kubernetes will take care of some of the scheduling or placement of applications inside of a defined set of resources. And that helps with isolation and efficiency. The CIO, perhaps for the first time ever, assuming you moved into Kubernetes in a serious way over the next couple of years, the CIO receives a database of what's running in production. We know what applications are running, what endpoints they're exposed on, what ports they're exposed on. If you're in a cloud platform, you might be able to see all the firewall rules associated with a given cluster. And because Kubernetes is an open source project that is not platform dependent, you are not locked in to Kubernetes. That was an individual perspective. Again, Kubernetes is a platform to run containers in production. It has value to individuals in the IT department, but it also has higher level value to organizations and higher education. Kubernetes might help you address broader organizational goals, such as embracing automation, while at the same time converging on shared building blocks to support team autonomy and self-service infrastructure. And all of that together at the same time, you're moving forward, but you're moving together, and you're standardizing, you're automating, and you're using better tools that are open source and out of the box, and they're cross-platform. We're not talking about WordPress or Moodle. You don't have to develop deployment frameworks for each of those websites. You have tools that Kubernetes provides out of the box to deploy and to monitor those systems. In higher education, you might find that centralization and standard application management procedures are a hot topic if you have sprawl of student mobile apps that are tossed over to your department to manage. And if you are feeling the crunch for providing more self-service capacity, you might find Kubernetes is valuable to you. So that was a little bit about what Kubernetes is. Again, Kubernetes is a container application platform to help you run containers in production. It has value to organizations and individuals in that organization. So let's talk a little bit about how you can quickly approach it. This is sort of the big takeaway from this presentation today, and we're going to I'm going to lay it out here, and then we're going to kind of dig a little deeper into Kubernetes and its architecture and how to approach it. But this is the main takeaway. So to succeed with Kubernetes, I'd recommend you use a managed Kubernetes service. I am not the first person to say this, but we want to maximize our gains from this transformational technology and minimize the overhead. It is a complex piece of technology, but it's especially if you use a managed service, you minimize the complexity. Kubernetes runs containers. You want to build ready-to-run container images to maximize the benefits with Kubernetes. For people familiar with containers, a familiar approach with Docker is to mount a volume with your source code on it. That is the approach I'm going to not recommend today because it's doable with Kubernetes, but you will not be able to capitalize on some of Kubernetes' most efficient features. Implement continuous integration and some type of deployment automation with Kubernetes. The deployment automation does not have to be to production. You could take your master branch and push it up to a staging or integration environment, but get some type of automation going so you can start to see and project out how you can use these advanced technologies to drive your processes forward. And two last points here about risk management. We want to defer advanced cluster features. Most of the advanced cluster features come into play when you have multiple units, multiple individuals, multiple applications running in the same cluster. Say you have two teams running in one Kubernetes cluster. There's advanced permission features that help you work with that. But if you're one team and your approach is based more on human trust rather than technical restrictions, you can ignore a lot of the advanced features for a while. And it might go without saying, it's a good idea to deploy low-risk applications first. If anybody looks like this right now, that's okay. I know today's conversation is about Kubernetes. You guys are experts in WordPress, but I want you guys to stick around and hold on and keep an open mind because WordPress fits into Kubernetes. I wouldn't be giving this talk today if we weren't talking about WordPress inside of Kubernetes. So let's dig down into defining a little bit more about the details of Kubernetes and how to approach it today. Kubernetes, as I've already mentioned, is a platform to run containerized applications. It was initially developed by Google in 2014 based on pre-existing systems inside Google. Google had released a couple white papers in the past about their internal container management systems called Borg. I believe that's still in existence, and a proposed successor named Omega. Omega never, as far as I remember, Omega did not see the light of day. Rather, its ideas were harvested and kind of merged with Borg's success patterns, and out came Kubernetes. Kubernetes was started at Google kind of as the third generation container management platform. And Google made a strategic decision to open source this software and later donate it to the Cloud Native Computing Foundation. Google is still a major contributor to Kubernetes, but they don't own the project at all anymore. There is wide enterprise support for Kubernetes. IBM, Microsoft, Amazon, Red Hat, and other companies have all recognized that Kubernetes solves real problems for these organizations, and they have bought into the ideas of Kubernetes. The KubeCon last year had over 4,300 attendees. So it's not exactly a small community in the open source world. And in the WordPress world, WP Engine and Pantheon both use or have stated intent to use Kubernetes in the future. So back to containers. Kubernetes runs containers. Most people are familiar, or at least have heard of, a Docker container if you do any type of development nowadays. Docker is a container runtime and also a company. Containers, though, are broader than Docker. They are back-end server-side software, not mobile applications. You're not going to see an iOS mobile application running in a Docker container. And what apps you see running on your desktop computer are probably not running in containers, although they might be. And your web browser is also not a Docker container. Containers use OS-level virtualization tools provided by the Linux kernel. In other words, they abstract the application from the underlying OS and provide us an abstraction layer that is focused on applications rather than hardware. We're not talking about CPUs, gigabytes of RAM, and gigabytes of disk space anymore. We're talking about endpoints for services and names of services, and it's an application-focused abstraction. The company Gartner estimates that 50% of businesses will run containers in production by 2020, and that is up from 20% in late 2017. I don't know about you guys, but 2020 is not that far away. It's at this time, it's only a year and a half, and so that's a big number that 50% of businesses are going to be running containers in production in a year and a half. Kubernetes is already used by over 50% of Fortune 100 companies today. So all that to say, this isn't exactly a passing fad. Containers are the base unit in Kubernetes. Kubernetes runs Docker containers. Kubernetes runs other types of containers. Containers make running applications easier. They're small, fast, and portable. And portability might be the biggest benefit here. There aren't, in some ways, you might argue that Docker containers don't offer lots of new approaches at the end of the process. At the end of the day, you're still running an application. For WordPress, it runs on a LAMP stack. At the end of the day, you're still running more or less a LAMP stack in a container. You're still running the Apache web server, a PHP backend, or built into the Apache server, and there's still a MySQL database. It's the same software running, but the containers package up each of those services with their dependencies. So that you can move them around. You can run a container on your local laptop and also run it on a data center machine or a cloud machine or your coworker's laptop. And so portability, in my opinion, is one of the biggest benefits for Docker containers. For people that are familiar with the WP Scan piece of software, it's a Ruby application to scan, to penetration test a WordPress blog. I know MacBooks usually have Ruby installed, but you still have to install the gems and the dependencies for this application. But if you run this command on the screen, Docker is going to go out, download a pre-baked set of images. So all it's going to do is download source code basically with all the dependencies ready to go, and it will be executable and let you get moving. So say you take this approach and make a WordPress container for your application. You run it on your local machine, it works, you have a few containers running, kind of a LAMP stack, and you share it with your coworker, and your coworker gets it working too, maybe with a Docker Compose file. You determine that you can deploy these Docker containers to production, because that's the big benefit. If it moved to your, from your machine to your coworker's machine, you can probably move it to the cloud or your production environment too. And that first deploy is exciting. You get those containers running on a machine. You install Docker, run those containers, and you map your DNS entries correctly so the traffic starts flowing, and that's great. Super exciting. I'm not kidding. I mean, it is exciting. You use the new technology. Later on, you determine you have to upgrade those containers and maybe build a new one. And maybe you want a different, maybe you need a different architecture, or you have a new container to run that's not WordPress, but it's on the same machine because Docker's installed. So you start to run into some of these problems. You need to restart the container, but that means downtime. The built-in host system update tools don't update your containers like they would have for an Apache web server, so you have to do that manually. So you start to add automation. But you start adding automation and suddenly you realize you're reinventing the wheel. You check out the Kubernetes homepage here and we see that Kubernetes is a piece of software that provides automated container deployment, management, and scaling for applications. Okay, let's pause. We're running containers in production, but we don't want to reinvent container orchestration and automation. It's a pretty good guess that Google's done that better than we have. Even if, and that's not to say that you couldn't also do great automation and solve a lot of the same problems with less code. But is that code worth writing and maintaining? That's an open question. So we're going to talk about how to approach Kubernetes as a developer today. We don't want to reinvent it, and the rest of this talk is not about setting up a Kubernetes cluster. So I want to make that clear at this point. The talk is more focused on using a Kubernetes cluster from an application administrator or developer's perspective. There's a great tutorial by Kelsey Hightower called Kubernetes the Hard Way that is increasingly the de facto manual for setting up a Kubernetes cluster from scratch. It's on GitHub. It is maintained, and he has different versions available because Kubernetes releases a new version every quarter, so it changes frequently. So check out Kubernetes the Hard Way if you're maybe more of a system administrator looking to stand up a Kubernetes cluster on a VM or a few VMs. All right, let's look inside a cluster. Kubernetes still requires machines to run. Kubernetes runs containers, but the Kubernetes software still runs on virtual machines or bare metal machines, and it can run in a data center or a cloud. Kubernetes is open source software. That's its big win. It's portable, and it doesn't lock you into any precise solution. The Kubernetes software is there's different components, and the components kind of fall into two main categories. The control plane or masters, they're the things that manage the cluster. So Kubernetes requires a cluster. It's not, you can do it on one machine, but typically you'll see multiple machines all talking to each other to run software. So therefore, Kubernetes is it's structured as a cluster of machines. And in that cluster, there are masters that run the main API servers, databases to maintain the cluster state, a container scheduler, and a lifecycle manager. All of those components are basically the orchestrators of the cluster. They are not your code. They are Kubernetes code, and they keep the cluster healthy. The worker nodes are where your application workloads exist. I have a picture in just a second that we're going to look at. It'll make more sense. But the nodes have fewer Kubernetes core components and more of your applications, or all of your applications. That's where your services and apps run. There's a tool called kubectl. It's basically SSH for Kubernetes. It talks to the main API server and lets you issue commands and see the database. Because Kubernetes does maintain a database of it has to track the current state of the cluster. Okay, here's the picture I was just referring to. This is a 4-node Kubernetes cluster. At the top, we see one node that is the Kubernetes master, and the node is a VM. I know it could be a physical hardware box in a data center. It could be a cloud VM. When I say node, I'm referring to a VM somewhere. So the master node in this picture is running just the Kubernetes core components. etcd is a modern distributed database. It works well in cloud environments. The API server is the main Kubernetes API server, and the scheduler and controller manager help manage the nodes. And they talk to the kubelet and the proxy service on the nodes. The 3 nodes below, so those 3 blue boxes, still VMs, and they could still be the same host OS, same layout as the master, but there'll be different software running on them. The white boxes, again, are the Kubernetes core components. And here's the interesting part. The yellow boxes are your applications and workloads. Most of your time is spent configuring the yellow box area and getting traffic into the cluster and directed at these pods and containers. This graph will come back up again later. I'm going to move on and talk a little bit about the pods, because that's where most of your time will be spent. A pod is a container abstraction in Kubernetes. It specifies a group of 1 or more containers. Kubernetes manages pods and not individual containers. Therefore, pods are the smallest deployable unit and the lowest abstraction layer in Kubernetes. Inside of a pod, there can be 1 or more containers. In the picture on the right here, we see a node with 2 pods, and each pod has a few different Docker containers running in them. Each of those Docker containers can talk to each other over localhost, and they can see some of the same. There are certain cases where they can see the same disks available, but not necessarily write to them. You could implement a LAMP stack as a set of 2 to 3 containers inside of one pod. I'm not saying it's doable. I'm not saying that's the best approach, but given this picture over here, you could imagine your LAMP stack translated into a pod, and it would work. Pods are rarely managed by you directly. You don't issue a command and say, make me a new pod. Pods are since they're the lowest level of abstraction, Kubernetes typically manages the pods on your behalf. You spend your time managing higher level objects, such as the deployment object. On the right here, you can sort of see a YAML-based spec for a deployment object. On line 3, you'll see that the type is issued. So we're talking about a object of type deployment, or excuse me, kind deployment. And this is basically a declaration on how to run your application. The YAML is a little verbose, and many people know that, but it's a machine. But this YAML is intended for machines, not humans. So beyond a little bit of the repetition and verbosity, just keep that in mind, that this is telling computers how to run your application. So it makes a little bit more sense when you end up repeating like the word Nginx 2 or 3 times on here that Kubernetes needs these different references to connect the different components. As you start to deploy applications in your Kubernetes cluster, you will spend most of your time here. You will define objects, push them into the Kubernetes database, and then a Kubernetes controller will, within its control loop, which is basically a continuous loop of checks across the cluster, it's going to drive the cluster toward the desired state that you define in these files. So if you declare Nginx needs to be deployed with 3 instances of it, and one instance crashes, Kubernetes will detect that right away and deploy a new container in its place. The deployment object here is very similar to a Docker Compose file. It's where you declare your environment variables, your volume mounts, multiple container definitions, and this is effectively how you deploy your applications into a cluster. The step that we've sort of skipped here again is building the containers themselves. Kubernetes does not automatically build a container for you. It doesn't take your source code and build a container. So Kubernetes is sort of the end game of taking that container and running it in production in a sane and manageable way. There's lots of tools and documentation around building containers though themselves. Typically that uses Docker still. Kubernetes runs Docker, so you can use Docker on your local machine and Docker in the Kubernetes cluster to build containers. This is the deployment object. There are different types of objects. There's an object called cron job, which I can imagine makes a little bit of sense, where you define a short-lived job to run on a certain time-based schedule. So at noon every day, run this container with this command. It's very similar to cron on a normal Linux machine. And there's other object types that are a little more advanced. One common one you might see is called a stateful set, which is very similar to a deployment object here, but a stateful set enforces an ordered pod rollout. A deployment object typically splatters all the containers against the wall in any order, and it just gets them running as fast as possible, whereas a stateful set has different properties and it's executed in a slightly different way. So say you need to roll out a MySQL cluster, you need the masters to come up first, and then the replicas. So the stateful set is designed for workloads like that. So you have a pod, which is your containers. You have a deployment object, which is defining all of the variables and configuration to run those containers and how they talk to each other. Now you need an abstraction to get traffic into the cluster and route it to the right location. One of those abstractions is called the service abstraction, and it helps route the traffic to your pod containers. Pods come and go. As I've already mentioned, that might be not. Pods come and go. You update your deployment object with a new container image, and Kubernetes will start deploying the new version of that container image. The service provides a stable identifier, very similar to DNS, that helps your applications talk to stable services, because pods are assigned internal IP addresses and they rotate, so you can't address services by IP addresses. Again, this is conceptually similar to how you would use the link feature in Docker Compose, where you say MySQL and PHP are connected. A service, it's not the same in Kubernetes, but you could, if you're when you're connected to the database, you're connecting to the MySQL service. It's an internal DNS reference. There's another object in Kubernetes called ingress, which I'm not going to go into detail today, but that's sort of how you get traffic into the cluster. If you use a cloud service, a lot of that is managed on your behalf. Again, a big benefit, but services are kind of internal routing and load distribution and balancing for your applications inside of the cluster. So let's put this all into action. Let's run a Docker container locally and then deploy it, the same the same Docker container that we ran locally, let's put it into a Kubernetes cluster. This example is going to use a hello world example. We could do WordPress, but it would not fit into a minute demo. So we're going to use a hello world example, and just know that this is all possible with WordPress and other things, but it would just take longer. We've started the container locally and issued a request to it and got a response. We're checking the logs of that container locally, and it looks like the logs are working, so we can stop it. We're going to use Google Cloud here, so we're going to ask Google Cloud to create us a new Kubernetes cluster. This is sped up a little bit here for the demo, but you can see that at the end we got a Kubernetes cluster in a minute or two, and now we're going to configure access controls to it. We're going to stop using the gcloud command here and start using the kubectl command. So we're moving from Google Cloud to Kubernetes CTL right now to manage the cluster. We have run a hello server image in Kubernetes, and it created a deployment object, which is going to deploy a pod. Now we need to get a service exposed with the right ports so that traffic can get to the hello server container. We can see that Kubernetes has received the assignment of an IP address from Google Cloud. There's some magic there that happens between Kubernetes and Google Cloud, but now we have a publicly routable service with the same container image that we were running on our local machine. Different host name, different timestamps, that's okay, but you can see that in a minute or so, we ran a container on my local machine and moved that container to the cloud and ran it with the same source code and dependencies. Now a little cleanup, and we are done. Oops. All right. So that was a hello world demo. We're going to get to WordPress, but first I want to talk about times when Kubernetes might not help, because the workloads in higher education are a little bit simpler in nature. There's a lot of websites and not a lot of applications most often, and some of these traditional website services might not be the best fit for Kubernetes. You can do it. You can have a web server that's running that somebody SFTPs their files into, maybe a shared local development, or excuse me, a shared hosted development environment where lots of web developers that aren't too technical, maybe they do mostly front-end HTML, CSS, JavaScript stuff, and they upload their files there and it all works and everything's lovely. And certainly web servers that are used by non-developers. If they publish websites from FrontPage or other ancient web publishing tools, some of those services will not be as adaptable to Kubernetes. You can do it, it's just going to be more complex, and you're not going to see a lot of value there. Databases are challenging, but getting better by the day in Kubernetes. Kelsey Hightower, again, he's the guy that did Kubernetes the hard way, setting up a cluster from scratch. Lots of people still strongly recommend using a database outside the cluster. The database is your state store. It's where all your information is stored. And if you lose that because Kubernetes deletes it, that's not great. So you want to extract the state from your applications and put them in more stable locations. There are lots of people building good tools around databases, traditional databases in Kubernetes, but at this time, MySQL was not designed in a way that is readily adaptable to a cloud and Kubernetes era. When things move around, names change, volumes get moved, and if you have a 20 gigabyte database, sometimes that might take a little bit longer to move. So if your application doesn't support missing its database for 30 seconds, it's going to be down. So you can run MySQL in the cloud, just acknowledge the risks and trade-offs of running that traditional database in, a Kubernetes cluster. It'll be better soon, and I'm going to let people smarter than myself pave that path. So what you do deploy in Kubernetes is stateless services. That kind of sounds like a buzzword. What I'm talking about here are services that don't persist data from session to session. For example, we run a memcached instance with our WordPress, but it doesn't maintain anything in memory that it needs to store between sessions. So we can safely restart it, just like clearing the cache. We can restart that memcache service, and it's okay. So it might not be stateless in the sense that it is definitely storing something in memory, but between sessions, there is nothing persisted on disk. That capitalizes on some of Kubernetes' best features of health checks and discoverability and resiliency. If that container crashes, Kubernetes is going to recreate it on my behalf without even bothering me. It's great. And they can scale too. So examples. What are examples of stateless services? Edge proxies, front proxies. Say you have a multi-tenant domain like your www.institution. Say you have some old websites, some new websites, some other servers, and you kind of want to push all of those through the same web server at the end of the day. An edge proxy is a nice way to handle that. We use Nginx for that purpose at Carleton because we have 15-year-old websites that are static on one web server, and we have a new WordPress web server that's sort of reclaiming some of those URL namespaces. Certain types of static web servers with content that doesn't change often. Certain applications that use external data stores. For example, we're soon going to be deploying an image server at Carleton called Tachyon. It's a WordPress thumbnail server, basically, that creates just-in-time images for any size based on the query parameters. So it's an image processing service. But this Tachyon application loads all of the images from Amazon S3. So it doesn't store any state locally. All we have to do is point it at a public S3 bucket, and then it's going to download an image, crunch it, and send it out. It is a stateless application, and it is a great fit for Kubernetes. And WordPress. WordPress can be done in a stateless manner. The approach to making WordPress stateless is not precise, and it's not even special to WordPress. It's more of an application architecture level approach that involves assessing where your application is storing state and kind of pulling that out of the application itself. The biggest place to start for WordPress is to use a plugin that outsources media uploads to a service like Amazon S3. Other cases, you might have other plugins that write files to the local disk or rely on bad assumptions of the disk being always present. Say if you have a plugin that assumes your images are on local disk, that's not going to work in Kubernetes in a stateless environment. And if you have logging that writes to special locations on disk, you'll want to kind of use standard log facilities so that you can still use your logs in Kubernetes. The takeaway here is it's not as hard as you think, and it's not WordPress specific. It certainly requires a little bit more discipline in the future as you assess plugins to kind of see, does this plugin call the read file method in PHP, and does it expect the disk to be fully available and kind of standard WordPress where the files are available on disk? If so, that plugin might not work for you. And the older your WordPress install, the harder this will be. But I know people are always still standing up new WordPress multi-site instances, so this is a good place to start because making this work in Kubernetes also makes it work in the cloud. You can take, it's the same process to kind of decouple your state from your application so that you can scale your application and stateful stores independently. That's not to say we didn't have issues when we were starting down this path. The first issue we ran into was a WordPress plugin. Shocker. Our image website, the first website we launched at Carleton College was the admissions website. It was a very image-rich website, and we needed a way to make lots of different sizes of thumbnails because it's fully mobile and responsive, and it's a very image-rich page. One of the plugins we were testing was a just-in-time image thumbnail creation tool. Locally, we were not using S3. In production, we were. So this is a classic case of dev and production being different. Even though at the WordPress level, it was just a plugin that we decided not to use. So in retrospect, we learned that that WordPress plugins are still an important part of making sure the development environment is like production. And then it gave us some information to pay more attention to when looking at new plugins to make sure that the plugins don't make bad assumptions. This particular plugin we were looking at assumed that the files were on disk, and that was how it was going to determine if it needed to create a new image just in time. It was going to check the disk for a file, and if it didn't exist, it was going to send it out. It didn't use any core WordPress APIs to determine if a file exists, so this plugin was not useful for us in our environment. You might be asking, I only have a few WordPress installs. Kubernetes sounds complex and risky, but another point today here is that you don't have to be Google or a big application provider to benefit from Kubernetes. You can start small. There's nothing wrong with running one application in a Kubernetes cluster because there's a lot of benefits. You get fully managed deployments and rollback procedures, configuration management, load balancing and distribution, and health checks. Health checks are one of my favorite perks of Kubernetes, where if you define your container images correctly with configuration and environment, Kubernetes will not direct traffic to your container image if it is incorrectly configured and fails to start. The example that I had recently was that I deployed bad configuration for one of our Nginx servers. I was missing a variable, and Kubernetes detected this, and the container produced an error when I deployed it. It did not start. However, there were already 3 existing containers of the previous deployment still running, and Kubernetes was directing all traffic to these old containers. So even though I had launched a bad configuration and the container crashed hard, Kubernetes detected this problem and did not send any traffic to it. So the service was completely still up and unaffected. I fixed the problem, and the next deployment went out well. Small clusters are great, but my sysadmin said it's going to take 3 months to do this, and it's only one cluster. With Google Cloud, Amazon, Microsoft's Cloud, and other managed Kubernetes services, you can maximize the transformational aspects, and not take on the overhead of managing Kubernetes. We at Carleton use Google Kubernetes Engine, and it's very stable and very simple, and it's not cost prohibitive. If you want to avoid the hassle associated with low-level plumbing, which you might run into if you try and run Kubernetes on premise, a managed Kubernetes cluster is the way to go. Again, and Kubernetes is open source, so what's running in Google Cloud can be, well, I shouldn't say, what's running in Google Cloud and Amazon's cloud, it's Kubernetes with a bunch of other integrations to their cloud services, which is why it's valuable. You have to do a lot of that work yourself on premise. So you see, we're back at this picture here. You want to define your applications in the yellow pods and deploy them there. That's where you want to spend most of your time. You don't want to spend most of your time in the blue boxes and the white boxes. Unless you're going to scale out Kubernetes across your whole institution, it's probably a wise investment to learn a little bit about it. But if you're just deploying applications or managing somebody else's applications in a cluster, use a managed service because it helps you focus on the yellow boxes, which are your workloads, and they add the value to your company and your organization. Carleton's deployment, we moved to G Suite a year or 2 ago. It's great for Google Cloud because we automatically get identity and 2-factor management built in to our cloud environment. That is huge. As of late 2017, Google Cloud also costs 10 to 30% less than comparable services on Amazon. That's a big deal. They tout it a little bit, but I would recommend doing the math. If you run basic compute and storage services on Amazon, it might be quite a bit cheaper in Google right now. And I've had experience with Amazon since 2009, and Google Cloud is a breath of fresh air. They have smart resource alignments. They have projects, which allow you to isolate your resources. So say you're running WordPress and Moodle in Amazon Cloud, all of those VMs show up in kind of the same dashboard in the same area. In Google Cloud, you can split those into isolated projects so that you're only in a Moodle project when you're working on Moodle VMs and configuration, and you're only in a WordPress project otherwise. As you start to scale out your cloud deployment to multiple teams and multiple projects that you don't know about, that's huge because you aren't worried about destroying somebody else's vital production resource. We use Cloud SQL, which is a managed MySQL service from Google Cloud, and Amazon S3 for media stores and object stores. The only reason we're using the Amazon S3 is because the plugins are a better fit for WordPress. Some of the Google Cloud plugins we ran into issues with, and so for WordPress, there's a plugin that works great with S3. I think it's just called S3 Uploads, is what we're using. And it works great, and the latency wasn't detrimental enough for us to notice. This is a boring slide, so I'm going to move on quickly. But inside our cluster right now, we've only been running Kubernetes in production for a few months, but we have a staging environment, a production environment, and a Jenkins continuous integration system. The flow of traffic from a user making a request all the way through. This is, in retrospect, kind of a confusing chart. The color codes are sort of meant to delineate the Kubernetes resources from Google Cloud resources, but obviously the Kubernetes nodes kind of in the middle are both, and our workloads are defined in this chart as the web server tier and the PHP backend tier. Those are our pods, and a deployment object in Kubernetes deploys these pods. One of the good and bad things about Kubernetes is you could make many different versions of this chart, and you could configure your resources in Kubernetes differently. You could eliminate the load distribution layer. You could combine the PHP and web server backends. There's different ways to approach this, some simple and some hard. That's the great part about Kubernetes, but I'm going to move on because I think this chart is a little misleading at the end of the day here. Jenkins we use for continuous integration. Our office sort of follows a trunk-based development where master is ideally always stable, and when we push to master, Jenkins gets a notification from GitHub and it starts to build a new Docker container, copying the source code into the Docker container. We also run our production deploys through Jenkins via a pull request. This is the Blue Ocean plugin in Jenkins, a little bit of a fresh take on Jenkins, but still kind of the same build pipelines. You can see here that we use Composer and Node a little bit to build some front-end assets for our websites, and then we build Docker images in the middle, and in this case we deployed to production. So the whole process took 8 minutes or so. All right, here is the recipe for success with Kubernetes. Use a managed service. And you can simplify and streamline at your schools. If you're a Google school, use Google's managed Kubernetes service. If you're a Microsoft school, use Microsoft's managed service. Build ready-to-run container images. You know, that might be the biggest change before adopting Kubernetes, but if you can get past that bridge, Kubernetes is going to come pretty quickly. Once you have Kubernetes, start doing some deployment automation and continuous integration to kind of capitalize on some of these new features to enhance reproducibility, better, safer deploys, and then you can start to see how you can move quicker with some of these fancy environments. Defer advanced cluster features until you have multiple teams running inside of a cluster or untrusted, unprivileged applications, and minimize your complexity and risk by deploying low risk things first. Bonus points, you know, as you start to test Kubernetes, try doing 2 different types of applications. Don't just do 2 instances of WordPress. Try WordPress and something else, maybe not even PHP. And there's a package manager for Kubernetes called Helm, and it can really expedite the process of deploying an application. There are alternatives to Kubernetes, Docker Swarm being one of them. It's certainly a smaller footprint, easier to get started. Some very similar pieces to Kubernetes, but there are no managed services and few cluster automation tools. So it's smaller, but there's less availability of it. And I know it's not. It has issues of its own too. So I was talking to some colleagues here at the conference, and they have networking issues with Docker Swarm. Amazon ECS is a hosted-only solution, and it's tightly coupled to Amazon Web Services, so it's worth considering if you're already there. But otherwise, I would stick towards more open Kubernetes services. And OpenShift is a distribution of Kubernetes that Red Hat produces. There's an open source version, and certainly Red Hat will gladly work with you to help run OpenShift on your own infrastructure or in a cloud, but it's Kubernetes, and then Red Hat bakes a lot of additional functionality on top of Kubernetes. And it's really a great product. We started our investigation there. It didn't turn out for us for a variety of reasons, but if you have to run on-premise, OpenShift might be a very valuable solution for you. A few links. These slides will be posted. There's a Udemy course called Learn DevOps. It's great. The Kubernetes podcast is full of great information, and Google Cloud's documentation has good quick starts on getting started. Thank you for listening.